Welcome class to our first assignment, problem 3-1 for CATIA orientation, CAT 31. Okay, so for our first video, I am going to go slow because I don't want to lose any of you. If at any time you get stuck, you find yourself going in circles, it's been over half an hour and you still can't figure it out, I suggest you start over again from scratch. Okay, so once you have CATIA open, most likely it will not take you to the workbench that you're going to use. So you can go ahead and close this window. Go ahead and close it. And we can go to Start. And we're going to the Part Design workbench. So go to Mechanical Design. And go to Part Design. I have shortcuts set up for myself. So I did change my settings for shortcuts. But in your case, yours is not going to show this. So go down to Mechanical Design, Part Design, click on it, and might as well name your part here, Problem 3-1, and hit OK. So once you name your part, it will also name it here at the top of the CATIA tree. So this is the tree. And also when you save your work, it's going to default to this name, Problem 3-1, unless you want to save it as a different file name. Alright, let's start by maximizing this blue window. So we can either maximize by clicking on this icon, or we can just double click on the frame. Either one will fill up the screen in CATIA, so double click or hit maximize. So we have CATIA open. Let's go ahead and maximize it. There it is. Alright, so as you can see, we have Problem 3-1, top of the CATIA tree. Now if you ever wanna, if in case your tree disappears, if you hit F3 on your keyboard, it'll disappear. Hit F3 again, it'll reappear. Okay, so in case you ever lose it, hit F3. Alright, so let's go to our first problem. Problem 3-1. Okay, notice it's in millimeters. So if you haven't done any changes on the settings for CATIA, it should default to millimeters. But if it doesn't, let me show you how to change the units. And in our lecture notes, and I will be providing a separate YouTube video for the lecture notes. If you need to change the units, you can go to Tools, Options. Once again, Tools, Options, and hit the plus sign on General. So here's a tree. If you hit the plus sign on General, it'll load up the branches. Click on Parameters and Measure. Go to the Units tab. And the first option is Length. There's a bunch of options. This is where you change angles, time, mass, volume, density, etc. So most likely it's in metric units, but you can always change it. So pick the first one, length, and then we can go to the drop down and we can choose inches, feet, etc. For us, we will be using millimeters for this assignment. Okay, so let me walk you through that. So once again, let's check our units. Let's go to Tools, Options. Most likely you'll have to hit the plus sign on General. And this is very similar to the CATIA tree that you see over here on the left. You can actually move it around, and you can actually do the same thing with the CATIA tree. Hit the plus sign, go to Parameters and Measure, go to the Units tab, and yours should default to millimeters using the metric system. If it's not in millimeters, click on Length, go to the drop down and pick the units that you want. So most of our assignments will be either in millimeters or inches. Okay, so for this one, we're going to go with millimeters. Hit OK. And now we are in millimeters. All right, so we're going to create a sketch. And we have to pick a plane to create the sketch on. It can be a plane or a flat surface on a solid. So if you go back to our to our notes. Don't forget that we are in part design. So we are currently in part design. How do we know? All we have to do is look at the upper right corner and it tells us which workbench or module we are in. Keep in mind, CATIA has over 100 modules. Always be aware of which module or workbench you are in. This will tell you we are in part design. Anytime you see the single gear, we are in part design. Once we click on sketch, you're going to see the icons change. So once we click on sketch and pick a plane to sketch on, it's going to look something like this. Okay, so this tells us that we are in Sketcher workbench. And you have all these commands to create your geometry. And once you're done creating your profile for your sketch, you can always hit exit and it'll take you back to part design. All right, so let's go back to CATIA. So we're going to create a sketch. So once you click on sketch, you're going to see the part design workbench change to Sketcher. So I click on sketch, pick a plane. I'm going to pick the YZ plane. You can pick whichever plane you want. I'll pick the YZ plane, the second one on the list. Click. And I want you to notice that now we are in Sketcher. You can always hit the arrow, the yellow arrow pointing upward to exit. And these are toolbars which have commands. You can always dock them if you like. You can always, just like a ship or boat, you can dock them. You can always grab them by the handle if you want to move them. You can also hit the shift key if you want to place them vertically if you like. I can always create a new column of tools. Again, hit the shift key to go horizontal or vertical. All right. I want you to notice that these are turned on. Anytime you see an icon lit up as orange, it tells you that it's on. If it's blue, it's not on. Okay, so some of these you do want to keep on. So for example, this one here is orange. So that turns on the grid in the background. If I turn off the grid, notice the grid is off now. Now it's blue. If I click on grid, it will show me the grid in the background. And this is anytime you go into Sketcher. About half of you will like the grid in the background. About half of you will prefer to turn it off. It's a matter of preference. What do you prefer? I like the grid in the background. Okay, it tells me I am in Sketcher. All right, so before we start sketching, a little exercise on how to zoom in, how to zoom out, how to pan, and it's all based off of the wheel. So in CATIA, it's a little different than SolidWorks. If you want to pan, move things left and right, up and down, hold the wheel. Okay, so you hold the wheel. So let me demonstrate. So if I hold the wheel, I can move left and right. I'm holding onto the wheel and moving the mouse. If you want to zoom, zoom in and out, you hold the wheel and you tap the right button. You hold onto the wheel, but release the right button. So you just tap the right button, but you keep holding onto the wheel, and you'll move the mouse up and down to zoom in and out. And to rotate, you click the wheel and the right button. You hold both of them down to rotate. Okay, so I'll demonstrate rotate and zoom towards the end. Might do zoom at the beginning of the sketch just to demonstrate it, and then once we exit the sketch, we'll do rotate. All right, so let's start sketching. Let's take a look at our assignment. Okay, so we're going to start with the profile of this object. Okay, we're going to use the profile command to create our profile. And we're going to guesstimate the size. So this is 140 in length, as you can see, 140. And then we'll go 115 vertically. And then we'll just guesstimate the length of the rest of it. and then we'll come in and add the dimensions in our sketch. And we'll save these two small features for the end. All right, so let's go 140 across, starting at the origin, 140, and then we'll go 115 up, and then just guesstimate the rest of it as far as the lengths, and then we'll come back and add the dimensions. All right, so I'm gonna pan to the left a little bit, and I wanna start at the origin. So I'm gonna hit the plus sign on the part body, hit the plus sign on sketch, hit the plus sign again. So I want you to notice that this yellow line with the V is our vertical axis. For the sketch, this is our vertical, and this is our horizontal axis. So instead of using an XY, CATIA for sketches uses H for horizontal, this is our X, and V for our vertical, that's our Y. And when this is 0, 0. Okay, once I go into profile, so we're going to create our profile. Here's the profile command. Once I click on it, the sketch tools is going to extend, giving me X, Y, Z coordinates and lengths. Okay, so here we go, profile. Okay, so it's already giving me the location. Notice how my cursor is snapping to the grid. I prefer not to snap to the intersections on the grid, so I'm going to turn off the snap. Here's snap. Click on it. Notice it's no longer snapping. I prefer to have snap turned off. Leave it up to you, what you prefer. All right, so we're going to start. Click at the origin. So this is 0, 0. You can see as my cursor moves over towards the origin that H and V coordinates will turn to 0. Okay, see that? 0, 0. So I'm going to click. And I'm going to guesstimate the length. So this is the length, and I want somewhere around 140, right? So as long as I'm close to 140, okay, close enough. I'm going to click. Then I'm going to go 1/15 upward, close enough. So look at length. Click, and then I'm just going to guesstimate the rest of the profile, and I'll come back and add dimensions. Okay, so I'm going to go in, down, and so on, and create this profile. So for now, I'm just guesstimating the location of the lines. And now I can close it. Make sure when you close your profile, notice that blue filled circle. That tells me it's picking the endpoint of the line. Okay, so there it is. And it's closed. Notice how it's orange. That means it's pre-selected. Click out in space, or hit the escape key on the keyboard. I'll just click out in space. And notice how it's no longer selected. Anytime you select an object, it turns orange. Either hit escape or click in space to deselect. All right, so now I'm going to show you once again, pan. To pan, I'm going to hold the wheel. To pan, move it left to right, up and down. If I want to zoom in and out, all I have to do is hold on to the wheel, tap the right button, just tap it. And then I can move the mouse up and down to zoom in and out. Another option is I can do a zoom fit all, fit all, and it'll do a zoom fit. And there it is. Okay, so now let's throw in some dimensions. Okay, so we have dimensions from the vertical going across 35, 77, 115, 140, and so on. So this is our datum to dimension from. And also the baseline is used as a datum to dimension vertically upwards with the 37, 115, 20, 40, and 75. Okay, so let's do the top ones first. Throw in some dimensions. Okay, so this will allow us to throw in some dimensional constraints. Okay, so click on it. If you're going to use an icon, a command, multiple times, if you double click, if I double click, I can use that command multiple times. So here we go. We're going to throw in our first dimension. Notice this is still orange, it's still active. So it's going to allow me to create more dimensions. Okay, so we threw in our dimensions. If you want to exit the command, you can either hit escape on the keyboard or just turn off the icon. Notice it's orange, it's still active. Turn it off and the command is no longer active. Okay, so let's go ahead and change these numbers. So we have 35, 77, 115, and 140. So all I have to do is double click, type in 35, enter, double click, type in 77, enter, double click, this is 115, enter, and double click, type in 140, enter. Okay, so we're done with these horizontal dimensions. Now let's throw in some verticals. Okay, so for the verticals, we got 115, we have 40, and 75. Let's do the 40 and 75 first. So instead of double clicking this time, I'll just click it once. From the base to this point is 40. Notice how, because I only clicked it once, then I have to go back and click again to add another dimension. That's 75. And instead of having to go line to line, I can just pick the vertical, then click to position it, and double click, and 115. All right, so now notice this line is white. Notice how all the others are green. So we want our profile and all our other geometry that we haven't drawn yet at the end to be green. When it's green, it tells us that all the lines have been positioned with respect to the origin, and it also has a length or a radius or a diameter. It means it's been defined. So if I was to try and left mouse click and hold this line and try to move it, it won't let me because it's already been defined as a length of 115. With respect to the origin, it's been positioned at 140, as you can see, 140 with respect to the vertical axis. Okay, so anytime you see a green line or green element, whether it's an arc, circle, or line, it's been defined. But anytime you see a white circle, a white line, white curve, it means it hasn't been locked in or defined completely. So if I was to grab this white line, I want you to notice that it's free to move vertically. Now the endpoints are locked in by these dimensions, but if I can move it vertically, that means we're missing a vertical dimension. So we can either put in a dimension, a constraint, dimensional constraint to lock it. But it happens to be that this line is in line with this one. So if we go back to the drawing, it's not clear, but it should be obvious that this line lines up with this one. So we're going to add a relationship between the two lines, and we're going to make them coincident so they line up with each other. Okay, so let's go back. So let me first click in space. So above the dimensional constraint, there's a relationship constraint. Right now it's grayed out because we haven't pre-selected anything. So I'm going to pre-select those two lines, and you're going to see this light up. Okay, so I'm going to hold on to the control key on the keyboard. That's the key on the bottom left corner. Hold on to it, click the two lines, And notice how now the relationship constraint command has lit up. I can now click on it and I can say, hey, what options do I have here? I can make them tangent to each other, perpendicular, parallel. In this case, we want them to line up with each other. We want them to be coincident. So you're going to see them line up with each other once I hit coincidence. There it is. They're in line with each other. And I want you to notice there's this little ring. So there's the relationship between the two. And it's defined by that little ring. Hit OK. So let's talk about constraints now. So in your sketch tree, there's, let me close the absolute axis branch, the geometry. So all the lines that you've drawn and the endpoints are included here. As you can see on the tree, this is the history of this sketch. Constraints. So as you were creating the sketch, it was creating constraints. It's hard to see, but here we have an H. That's for horizontal. Same thing with this one. We also have a vertical constraint. So let's go back and once again from our notes, I'll do a separate YouTube video for the lecture notes. Anytime you see H, it's horizontal. I know it's lighting up as parallelism. It just means it's parallel to the horizontal axis. Just like the V is vertical, it's parallel to the vertical axis. And we have parallelism, we have perpendicularity, 90 degrees. We have coincidence, concentricity, meaning the same center point is shared by two circles or a circle and an arc. We can also anchor or fix a line or an endpoint. Okay, so now let's go back, take a look at the constraints. So even though it says parallelism for H, what it's really telling us, it's, hey, this line, yeah, it's horizontal, and it's parallel to the horizontal axis. Here we have V, right? So V is telling us parallel. It's parallel to the vertical axis. All right, let's take a look at some of these other constraints. So the dimensions are defined as offsets, as you can see. You can always right-click delete. If you ever need to delete a constraint, you can always right-click delete, or you can select it and hit delete on the keyboard. All right, so one thing I do want to mention is over-constraint elements. What happens when they're over-constraint? So you want to see green, right? You want everything to be green. Everything's been defined. It's been located. You have the sizing done. But once in a while, you'll come up with purple or magenta color telling us that it's over-constrained. You have over-defined it. You have too many constraints, too many dimensions, too many relationships. So let me duplicate that. So for example, this dimension here for this line, it's 140 minus 115 is 25. So this is obviously is 25. I can double click on it and it'll tell me, even though it's grayed out, I cannot change it. It tells me it has a length of 25 and it's at an angle of 180, and it also gives me the coordinates of the endpoints. Let's say I was throwing a dimension in there. So I click on constraint, dimension. Notice it turns purple. So it's telling me, hey, let me zoom in. It's telling me you have too many constraints. We know this is 25 because we know that 140 minus 115 is 25. You don't need the 25. It's already defined by these two lines, the endpoints. As you can see, the endpoints are defined by the 140 and the 115. So what happens is these three dimensions are fighting each other. They're fighting each other. And it really comes down to which one is more important. Since we dimension with respect to a datum, left to right, or it can be right to left. Either way is fine. Then we can say, you know what? This 25 is the least important of the three. So we need to get rid of this one. And I want you to notice that there's a yellow swirl. So anytime you see a yellow swirl, it's telling us it's fighting the other dimensions and it's causing this magenta color. So we can either delete it from here or delete it from here. Right click delete. And that'll get rid of the over constraint, which was shown in magenta. Now it's green, so we're all good. Okay, so now let's go ahead and finish up this drawing. Okay, so we're going to go back to the handout, and we're going to draw the circle. Okay, so the circle, it's located at 22 by 37, or I should say with respect to the corner at 22 and 37. Okay, so let's go ahead and draw the circle. Okay, so if we go back to the profile, there's profile, and if you go 2 down, that'll give us the circle. And there's a lot more options if you want by clicking on that little downward arrow. We'll come back to that later. So let's draw a circle. And we're going to go ahead and locate it. We're just going to guesstimate the location. Notice how as you're creating the circle, it's trying to create a relationship with respect to other dimensions. As you can see, it's trying to create a tangency. I'll just allow it. I'm going to go ahead and click to create the circle. And I want you to notice in the tree that it created a tangency. A tangency between the circle and the slope. We didn't want that. We'll come back and fix that. Okay, so now I'm just going to click in space to deselect. So just click in space. And now let's go ahead and add those dimensions. Alright, so we're going to go to the center of the circle. I know it's hard to see that little gray dot, but there's a little gray dot right in the center of the circle. Click on it. And now we're going to click on the base. And now we can add our vertical location. And now we need our horizontal. So let's go ahead and add another constraint. So once again, we're going to go to the center of the circle. I know it's hard to see that little gray dot. There it is. Click on it. And then we're going to click on the vertical. And now we have our vertical and horizontal location for that hole. Let's go back to the handout. I did forget what the dimensions were, and we also need the diameter. We need the diameter from the handout. Okay, so as you can see, the hole is located at 22 and 37 with respect to this vertex, and the diameter is 19.5. So let's go to 22 and 37. So I'm going to double click, change this to 22. Enter or hit OK. And the vertical is 37. Hit enter or OK. And we still need the diameter. Okay, so the circle is green because the diameter is being defined by this tangency with respect to the slope. So we're going to have to end up having to delete it, but let me first throw in that diameter just to show that it's going to over constrain us on the circle. So let's go ahead and click on the dimensional constraint. Let's click on the circle and give it a diameter. Notice how it's way over constraint. And click to position it. And now we're going to go in and change the diameter to 19.5. Double click. So 19.5. By the way, if you want to type in a radius, you can always go to the pull down here and pick radius. So you have an option when it comes to a circle or an arc to type in a radius or diameter. If it's a circle, go with diameter. If it's an arc, go with radius. Okay, so it's 19.5 diameter, and hit OK. Now, it's magenta because we've over constrained it. So the 19.5, if you look on the tree, it tells us, hey, something's wrong. You see the yellow swirl? It's telling us it's fighting another constraint or group of constraints. So in this case, it's the tangency. So if I go up to the tangency is not allowing the 19.5 to do its job with the diameter. So I can always right click it. So there's the tangency. We don't need that. It's not part of the drawing. So we can just go ahead and delete it. And now there it is. It's free to be at 19.5. So that tangency was preventing it from being 19.5. All right, so now let's go ahead and go to slot. The slot is measured center to center at 35, and the first center point is located at 20 and 20 for our vertical and horizontal. And the radius is 7.5 on the slot. Okay, so we're going to use the elongated hole command to create our slot. It's one of my favorite commands in Sketcher. Okay, so to get to that command, you have to go to rectangle, and there's this little downward arrow to give you more options. If you click on it, it gives you more options. And we're going to go to slot or elongated hole. Okay, and I'm just going to guesstimate its location. We'll come back and add the dimensions. So I'm just going to click, and click to define our radius. So I'm just guesstimating the size. And as I mentioned before, I want you to notice that in the sketch tools, these are orange. So because these are orange, these are on. When these are on, it's creating constraints. So if we go back to the slot, it created tangencies. As you can see, you have 4 tangencies, the arcs and the lines. There's tangencies. And there's also that horizontal. And there's also an offset to represent our radius. So this is the offset. Okay, so let me first click out in space to deselect, and let's go ahead and add those 20/20 dimensions. Okay, so we're going to go to dimensional constraint. Click on the center of the arc on the left. There it is. It's hard to see, but there it is. And then we're going to click on the vertical line. That looks like I misclicked. Let me click again. Click. There it is. So we know that's 20. Let's double click, change it to 20. So you can type in 20 and you can either hit enter or hit OK. And let's do our other 20. And we're going to go with respect to the horizontal. So we can either pick the green line or the horizontal axis. Either one is fine. Okay, we'll change that to 20. And by the way, if at any time on this assignment, if you type in the wrong dimension or the wrong radius, I'm not going to take points off. Okay, so, or if you did it in the wrong units, if you used inches instead of millimeters, I'm not going to take points off. All right, and then we need the length of the slot from center to center, which I believe is at 35. Yes, so once again, I'm not going to take points off from your assignment if you type in the wrong dimension, the wrong number. All right, so let's go ahead and change this to 35, I think it is. And let me just double check on the dimensions. Yes, it's 35 on the length of the slot. And the radius, so for arcs we use radius. For circles we use diameters. Okay, so 7.5 for the radius. So we don't need to bring in a radius. We're going to use this offset that it auto-generated for us. Oh, looks like I misclicked. Let me hit escape. Hit escape on the keyboard. I meant to click on this 10 point, this offset. So that's going to be 7.5. That offset actually represents our radius, and enter. And there it is, we're done. All right, so once we're done, we want to do a tool sketch analysis. Tool sketch analysis. So this will allow us to check if there's anything wrong with our sketch. Sometimes there's geometry out there in space that's not supposed to be there. And when you try and turn the sketch into a solid, it'll give you an error message. So anytime you do a sketch, you want to see closed. So we have 3 profiles. We have the circle, the slot, and then the overall profile. So you can see the first one is the circle, and it's closed. The second one has 9 curves. It can be lines also, right? So we have 9 curves or lines defining our main profile. And then the third one is the slot made up of 4 curves, the 2 arcs and the 2 lines, and it's closed. And that's what we want to see. We want to see closed. If it says open, something is wrong, and it's not going to be able to generate a solid from it, or a pocket or a hole, etc. All right, so let's go ahead and click close. So we're good. So everything looks fine. And let's just go back to the lecture real quick. So we're done with this sketch. But what happens if it's not closed? So when you do a sketch analysis, and it shows open, what you want to see is look for these cyan circles, like these double circles that you see here. So it's a circle inside of a circle. So anytime you see cyan on a sketch, that's a bad sign. Either the endpoint is not connected to the other endpoint of a line, so there's a break in your profile. And sometimes the breaks are so tiny they're hard to see. So you look for those magenta, or my mistake, cyan circles, and that'll tell you most likely either there's a gap or the lines are overlapping. So it's telling you it's not connected. Okay, so look for the cyan circles anytime you use sketch analysis. Everything was closed, so we didn't get them, so we're good. All right, so let's go ahead and exit our sketch. So we're done. Everything looks good. Our sketch analysis told us that everything was good. So now we can hit the yellow arrow to exit our sketch. Once we exit sketch, it'll take us back to part design. All right, and just as a sanity check, we're going to take our sketch and turn it into a solid. Computer went a little slow. I'll just let it keep going because we're almost done anyway. Well, seems like CATIA is not It's not responding. Alright, so let's give it a few more seconds. If it doesn't go back to part design, I'll end this YouTube video. Yeah, I'm gonna go ahead and end the YouTube video, and I'll start the second YouTube video for problem 3-2.